We're now going to look at the use of a checksum for error detection. Now, with a checksum, all the bytes in a block of data are added together. Now, if there is 8 bits blocks of data being sent at a time, that means there's 256 combinations. Each of those blocks of data could be in values. So we get our addition of all the actual bytes together and we divide it by 256. Now, this value is not the checksum. It is the remainder that is the checksum, which is then sent as a binary digit to the receiver. The receiver will do the same calculation. If it ends up with a different checksum, it is considered that there is an error. Otherwise, the data is fine. This checksum is commonly used in conjunction with the TCP protocol. So let's look at a scenario. We're going to send 6 8-bit packets of data, meaning that we have to divide it by 256. The 7th packet will then be the checksum. So we're going to add the numbers together. 2 plus 5 plus 15 plus 116 plus 140 plus 170. This gives me the number 448. So because they're 8-bit packets, I'm going to divide it by 256. 256 goes into 448 once with a remainder of 192. Therefore, my remainder 192 is turned into a binary digit, which becomes my checksum. This will now be transmitted to the receiver. If they are going to do the same calculation here, and any other result received other than 1100000 for its checksum will be an error. Another scenario here with larger numbers. So 172 plus 170 plus 120 plus 233 plus 204 plus 171. Here my value is 1070. So once again I divide it by 256. This time 256 goes into the value 4 times, 1024, with a remainder of 46. So in this scenario, 46 is my remainder, 101110 is my checksum. Okay, so that's how we get our initial values for checksums. Now other things can be applied too. Because the value 0 can cause errors, we need to have other methods set up to avoid getting a 0 value, because they can cause errors in software with a blank data piece coming through. So sometimes we merely reverse the checksum, so turn the 1s to 0s and 0s to 1s. That way, if they were all 0s, they'd all be 1s. Now the other situation would be if they were all 1s, we don't want to turn it to all 0s. So in order to protect our most significant bits, our MSBs, we can also add what's known as a carry bit. So let's take my initial checksum. I'm going to add a carry bit of 10. So that gives us 11000010. I then reverse it, and that becomes my final checksum. So once we actually do all these processes to our checksum, our error is only about 94% chance. So checksum is quite a valid piece of error detection method. Okay, so give it a try.